Hey, it's Mr. Donahue again, this time taking a look at 25.6 stuff, which is going to be carbonyl containing compounds. Or our objectives will be to draw a name and describe the structures and properties of carbonyl containing organic molecules. I've actually made a separate video for naming these things, okay? But yeah, that's our objective. So, carbonyl groups, you got to remember that carbonyls are basically carbon with a double bonded O attached to it. So that's our carbonyl group. A carbonyl group is, yeah, that's what I just said. It will influence the properties of the molecule, and its influences will vary based on what else is there. So it's basically going to be, you know, functional groups that have carbonyls in them, which are multiple kinds. We have aldehydes, we got ketones, not ketones, ketones. And we got carboxylic acids, we got esters, we got amides, and I'm also throwing amines, which doesn't actually have a carbonyl group, but I didn't want to leave it out. All right, so aldehydes. So aldehydes have the carbonyl group that is on a carbon that has one hydrogen on it. It's basically on an end carbon. So you're looking for this right there. That's how you know you have an aldehyde. The suffix for it is going to be al. So this would be like propanal. We'll get into naming more later. Just know that al is the suffix and it comes from the aldehyde. Right, so ketones are a lot like aldehydes, except that carbonyl group is on a middle carbon. It's not on the end. So the way I remember this one is that ketones has the O literally in the middle of the word. So you're looking for an oxygen that's in the middle of the carbon chain. So it's less reactive than aldehydes. They're used in solvents, and the carboxyl group is found on the interior of a carbon chain, so it's surrounded by carbon atoms. And aldehydes and ketones are created by the oxidation of an alcohol. So you can start with an alcohol and you oxidize it using some oxidizing agent, and then it's going to kick off that hydrogen and make a double bond there, and you end up with an aldehyde or a ketone depending on where that alcohol group was. If it was on a terminal carbon, then you get an aldehyde. If it was in the middle, you get a ketone. Our carboxylic acids, which you will see written as COOH, and the reason they do that is because you have C with a double bond O and then an OH. So instead of saying like CO2H, you'd be like, well, I don't know how any of that's bonded. You'll often see the COOH. So how is it an acid, right? It's a carboxylic acid. I thought OHs were bases. What's going on there? Well, the reason that it is an acid is because what happens is we got this oxygen pulling electrons towards it, right? So it's pulling electrons, especially with that double bond. It's hogging up those electrons, which is going to weaken that OH bond. So this hydrogen is going to be more likely to get kicked off. So let's say it gets kicked off, and then what happens? Well, let's take a look at what the structure is after it leaves. Well, I got a double bond oxygen here, and I got an oxygen with a minus sign here. Why couldn't I have done this? Well, you could have. They're both equally good, which tells me that it has resonance, which means it's really stable without that hydrogen. So that hydrogen is going to be likely to kick off, which is how it's an acid. It gives off that hydrogen, H+. All right, so they're weak acids, and they're common in fruits. So they're also used in the manufacturing of polymers, in fibers, and in paints, and a bunch of things. So carboxylic acid is really important. And it's made from the oxidation of alcohol. So if you go and you take the alcohol and you oxidize it once, you can get an aldehyde or a ketone. The ones that are aldehydes, if you keep oxidizing it, you can get the acid. And this is what's responsible for wine turning into vinegar. So what happens is you have your ethanol, which is your alcohol found in wine and other alcoholic beverages. You oxidize it and you end up with an aldehyde. And then if you keep going, you end up with an acid, and you end up with acetic acid, which is vinegar, right? So that's how wine can turn into vinegar. Esters. So esters basically took the H of a carboxylic acid and you replaced it with a group that has a carbon, right? So this right here used to be something that looked like this, and then went, hey, reaction, get rid of that H and add something that has carbons on it, right? So that is an ester. And it can be made by the condensation synthesis with carboxylic acids and an alcohol. So basically, we're going to remove water, right? So you take the OH from the carboxylic acid and an H from the alcohol, and you get out of that water. And then those two molecules are now going to be bonded together at the oxygen, making an ester. Right? And you can kind of see it. Like if you ignored all this, that almost looks like an alcohol. And if you ignored all this, that almost looks like an acid. So you can kind of tell what makes them up. Right? Cool. They also have nice odors, and they're found in fruits. So things that smell nice, like banana or strawberry flavoring, they're esters, right? You can also break it into an acid and alcohol by hydrolysis. So hydrolysis, hydro means water, and lysis means to split. So condensation synthesis is going in one direction, and hydrolysis is going in the opposite. They're the same, but doing the opposite. All right, some other things about esters. Fats are naturally occurring esters, right? So you get your glycerol and you get your fatty acids and you bond them together and you have these ester groups. So a fat is generally a big long ester all linked together. So hydrolysis of fats in the presence of hydrolysis of fats in the presence of a base is known as saponification. And guess what you make from saponification? You make soap. Now don't get the spelling confused. It's saponification, not soaponification, but saponification makes soap. Okay? So basically what happens, let me go back, is you're going to break these things off in the presence of a base. And what happens is, all right, well, it's going through hydrolysis. So you end up with one end that has like a salt, a polar area. Like if you're using sodium hydroxide, you'll end up with this, and then you end up with a really long chain. And I think I've talked to you guys before about how soap works. It's really cool. So this end is going to be hydrophobic or non-polar. It's afraid of water. It likes to hang out with dirt and oil and grease and stuff. And then this end is going to be polar, and it's going to be hydrophilic. It likes hanging out with water. So what happens is this end is going to hang out with all the dirt and surround it, and then this end is going to stick out into the water, and you'll be able to remove the dirt. Cool. Amines. So one or more hydrogens on ammonia are replaced with a carbon group. It's basically you got that NH3, but you got rid of one of the H's and put a carbon on there somewhere. These are organic bases, and the reason they're organic bases is because this nitrogen has an unshared pair of electrons, which it can donate for bonding, which would be making it a base. So yeah, amines tend to be basic. Amides. Basically, you got an amine group that underwent condensation reaction with carboxylic acid. So you got your amine group, you got your carboxylic acid, and you're getting rid of one of those hydrogens in the OH on the acid, taking out water and linking those two molecules together, making this. These are really important in proteins and in natural like biochemistry stuff because they make proteins. So, okay, tell me, what can you say about these things? What can you say about the different functional groups that have carbonyl compounds? What can you say about, aldehydes, ketones, amides, carboxylic acids, and even amines? What can you say about those? All right, hope you found that helpful. See you in class. Goodbye.